In this video, we are looking at vertical motion under gravity. If we ignore air resistance, every object will accelerate to Earth at the same constant acceleration. So it doesn't matter what the object is, it could be a brick or a feather. It's accelerating at 9.8 meters per second squared, and we call that G. So acceleration due to gravity, we call G, and to one decimal place or two significant figures, it's 9.8 meters per second squared. There are more accurate values of G, but we're just using this one. So because we're using a rounded value to two significant figures, it's a good idea to also give our answers to two significant figures. So because we're using a rounded value, that impacts the accuracy of our answers. Let's look at a question. A ball is dropped from a point 2 meters above the ground. Part A says find the time it takes the ball to reach the ground. So we have Suvat 2 meters above the ground. That's the displacement. It's dropped, which means its initial velocity was 0. We're looking at vertical motion under gravity. So the acceleration is G, which we're going to use as 9.8. And we want to know the time. So we're going to use the formula without V in it. And that is S equals UT plus half AT squared. So we have 2 equals 0 times T, which is 0, plus half times AT squared. So 2 divided by half of 9.8 will be T squared. 2 divided by half of 9.8 is T squared, so square root the answer, and we get 0.64 to two significant figures. So because we've used a rounded value of G, we're going to give our answer to two significant figures. Part B, find the speed at which the ball hits the ground. So we've got two options. We could use any formula with V in it. So we could use V equals U plus AT using our previous answer. Or we could use the formula without T in it, which is V squared equals U squared plus 2AS. And that will leave us with, so V squared equals 0 squared plus 2 times 9.8 times 2. So 4 9.8s is V squared, square root the answer, and we get 6.3 to two significant figures. So 6.3 meters per second squared, and we're given our answer to two significant figures, again, because we use the rounded value for G. One for you to try. Give it a go. So a ball is dropped from 10 meters above the ground. It doesn't seem like there's enough information, but there is, because we know the initial velocity is 0, and we know acceleration due to gravity will be 9.8 meters per second squared. So the formula without V is S equals UT plus half AT squared. And that's 10 equals 0 plus half of 9.8 times T squared. So 10 divided by half of 9.8 is T squared. Square root it for T, and we get 1.4 seconds to two significant figures. Find the speed at which the ball hits the ground. So we could use V equals U plus AT, but it's probably better to use V squared equals U squared plus 2AS, because we don't have to use our answer from part A. So v squared equals 0 plus 2 times 9.8 times 10. 2 times 9.8 times 10 is 196. So v is 14 meters per second. Here's another question. A pebble is projected vertically upwards with a speed of 30 meters per second. So now we've got a positive initial velocity and we're going to have acceleration acting downwards. So we're going to have to use a negative sign to show the direction. So if we say that going up is positive and going down is negative, so we've got suvat. Find the greatest height above the point of projection reached by the pebble. So at the greatest height reached by the pebble, the velocity will be 0 because the velocity is positive when it goes up and it slows down, and then it's negative when it goes back down. So at the highest point, velocity is 0. The initial velocity is 30 and its acceleration is negative 9.8. So it's decelerating, not accelerating. So it's negative 9.8 because it's slowing down until it reaches the top. And we want to know the displacement at the top. So what's the formula without a t in it? That's v squared equals u squared plus 2as. So we have 0 equals 30 squared plus 2 times minus 9.8 times s. So 30 squared is 900. 2 9.8s is 19.6. So I'm going to plus the negative 19.6s to both sides. So 19.6s equals 900. S is 900 over 19.6. And I get 46 to two significant figures, 46 meters. Find the time taken to reach this height. So I'm going to use v equals u plus at now. So 0 equals 30 plus minus 9.8 times t. So plus the 9.8t to both sides. 30 divided by 9.8. And that is 3.1 seconds. One for you to try. See if you can give it a go. So again, we've got the pebble projected vertically upwards. Its initial velocity is 20. Its final velocity is 0 because we want the point where it reaches its highest point. Acceleration is negative 9.8 because it's acting downwards. And we want to know the displacement. So if we use v squared equals u squared plus 2as, we get 0 equals 20 squared plus 2 times 9.8 minus 9.8 times s plus the 2 times 9.8s to both sides. So we get 19.6s equals 20 squared, which is 400. So s is going to be 400 divided by 19.6. and we get 20 to two significant figures, 20 meters. Find the time taken. So v equals u plus at. 0 equals 20 minus 9.8 times t. So plus the 9.8 t to both sides, divide by 9.8, 20 over 9.8 is 2.0. So 2.0 seconds. And one more question. So this time a stone is projected vertically upwards from a point x meters above the ground with a speed of 20 meters per second. After 5 seconds, it hits the ground. Find the value of x. So it's projected upwards from a point, and then it hits the ground somewhere below that point 5 seconds later. So we know that time is 5 seconds. Initially, the velocity was 20. Acceleration is going to be minus 9.8. So it's acting down. So let's call it minus 9.8. We want to know the displacement. We want to know how far it's gone down. So we want to know S. The formula without V in it is S equals ut plus half at squared. So we have S equals 20 times 5 plus half of minus 9.8 times 5 squared. So ut plus half at squared. And we get minus 22.5. So it's gone down 22.5 meters. So the value of x is 22.5. So x is 22.5 meters. That's the three significant figures, which is okay, but if you give your answer to two significant figures, it will be 23. Find the speed at which the stone hits the ground. So let's use v equals u plus at. And that's going to be 20 plus minus 9.8 times 5. 20 plus minus 9.8 times 5 is minus 29. So the final velocity is minus 29, which means the speed, because speed has got no direction, it can't be minus 29, it's just 29 meters per second. Okay, a question for you to try. See if you can give it a go. So the particle is projected vertically upwards. After 5 seconds, the particle is moving downwards with a speed of 12 meters per second. So the final velocity is negative 12 because it's moving downwards. Acceleration is negative 9.8 because that's acting downwards. And it's projected upwards. After 5 seconds, time is 5. We want to know the speed at which it was projected, which is u. So the formula without s is v equals u plus at. So it's negative 12 equals u plus minus 9.8 times 5. So minus 9.8 times 5. 5 times negative 9.8 is negative 49. So minus 12 equals u minus 49. So plus 49 to both sides. So we've got negative 12 plus 49, and that is 37. So u is 37 meters per second. Find the greatest height above x reached by the particle. So we actually don't want to know the displacement for this suvat. We actually want to write suvat out again because we want to know when the velocity at the greatest height, velocity is 0. So initially it's 37. Acceleration due to gravity is minus 9.8, and we want to know displacement. So we've got to write suvat out again with our new information because we want to know where it's at the top. We don't want to know when it's moving downwards with a speed of 12. We want to know when it's at the top. So we're going to use the formula without t, v squared equals u squared plus 2as. So 0 equals 37 squared plus 2 times minus 9.8 times s. So we're going to have 19.6 s equals 37 squared. Plussing the two 9.8s is 19.6. So plussing the 19.6 s to both sides, and then divide by 19.6. So 37 squared over 19.6 is 69.8, so 70 meters to two significant figures.